Hey everybody, it's Yehuda Sunshine here, head of PR at Odix. I'm here with our CTO Omri Eytan, and we're here to talk about CDR technology and sandbox. Omri, would you like to take it over from here?
Yeah, sure. Thanks, Yuda. Let me just quickly share my screen. There we go. Okay. So I'll be quickly going over the various common techniques used for in cybersecurity for file analysis, compare them and see how they can be used together to achieve a robust file channel security strategy. So first we have the legacy AV that we all know since the 80s. Legacy AV scans a file against a known list of signatures. It scans the data in the file in an attempt to find these signatures. And of course, if a signature is found, then the file is blocked, deleted, quarantined, or dropped. And if the file does not match any known signature, then the file is deemed safe. So in this case, we have an unknown malware, for example, a 0-day or an advanced tailored attack. So the legacy antivirus will not be able to detect it because it does not have the signature that knows how to detect this specific piece of malware in its database. So the file will pass the legacy AV check and will be deemed safe. But if we look at the pros and cons, then we have legacy AV being very fast. They're scanning the binary data, looking for the signatures with their DB. Nothing too fancy compute-wise going on there. These engines are relatively cheap and affordable. There's a lot of competition for a lot of years going on, so you can get them for relatively low prices. On the cons, we have the fact that they're easily bypassed. They're not really designed to deal with modern threats and more evasive techniques that we see today. And of course, they are not great with 0 days and new attacks. One of the options that we've seen using antiviruses is to kind of layer multiple engines and use them as a kind of meta scanner to scan files. So this increases the detection rate and provides for much higher detection rates, even for unknown files, because some of the engines have heuristics and can do some tricks to provide detection. But still, this comes with an increase in false positives, which hinders business. Next is the sandbox. Sandbox is a fairly recent technology. And the basis of it, a dynamic analysis is performed on the file. It is put in a virtual environment and is launched. And the sandbox monitors the behavior of the file to look for any specific behaviors that are deemed to be malicious. So the file goes in, executed, launched, sandbox scans it, and if the malware is activated and performs some malicious actions such as encrypting data, communicating with a blacklisted URL, and so on, then the file is deemed malicious and blocked. But if the file does not express any malicious behavior, and there is a lot of material out there on sandbox evasion and samples in the wild on how malware knows to detect that it is being analyzed by a sandbox and stay dormant. So in this case, the malware will not will not show any malicious behavior, and the sandbox will deem it safe and will allow it to continue. So on the pros, Sandbox has a very good detection rate. It is able to efficiently deal with 0 days and unknown threats. It doesn't need to know a file to deem it as malicious. But on the cons, it is a fairly slow technique. High latency can reach up to we've seen cases of 5 and even 10 minutes in certain environments, which might be acceptable in some channels, but of course not in more immediate transfer channels such as emails and chats. Sandboxing is also relatively expensive. You can think about the cost per file. For each file, a virtual environment needs to be set up. It's very compute heavy, it's very resource heavy, and it translates into the entire system being expensive. And Sandbox is also very environment specific. So we said that the file will be launched in a virtual environment. So that virtual environment has a specific operating system, specific applications, settings, which might be a problem if you have a very diverse endpoints in your environment. Then you will need a sandbox that has an operating system matching each of the endpoints, and of course, if not everything is up to date and the same apps installed, then that will be needed to be taken into account as well. And we also, last we have CDR. CDR stands for Content Disarm Reconstruction. It's a term dubbed by Gartner a few years back. What CDR does, CDR is a detectionless method that knows how to look at the content within the file and can think of it as a filter that allows the system admin to configure which of the content types within the file are allowed to pass. So according to configuration, for example, in this file, you can see that images, text, and Excel graphs are allowed. There are some manipulations that they undergo to make sure that any vector that they might have had will be disarmed during the process. And in this case, you can see that code, for example, macros and Office files or JavaScript and PDF was configured to just be dropped and removed. And from this disarmed content, a new document is reconstructed without any malicious vector in it and brought in to the user and used in the environment. So in the pros, CDR is very fast. It can process a file in a matter of milliseconds. Of course, this is type dependent. It is affordable and it is detectionless, meaning that it can disarm 0 days and unknown threats because it does not need to detect them. And on the cons, CDR is very good with data files, documents, images, audio, video, HTML, and so on. It's not really intended for executables, dynamic libraries, and it's not effective in dealing with them. And as you've seen, CDR also alters and manipulates the file. So that's something that needs to be taken into account. There are certain scenarios, such as legal scenarios, where files cannot be changed or modified because they need to be put in as evidence in court. So an altered copy will not do in that scenario. So knowing what we know about all these methods, we can try and connect all of them to create an effective file security strategy when our goals are to maximize detection and prevention rates. Of course, to minimize latency and business impact, so users won't need to wait unreasonable amount of time for their emails to arrive, etc. And of course, as always, to optimize cost, because we need to show an ROI for everything that we do. So how will we put these engines into play? So you can see that on the left, we have the multi-AV engines that will scan everything coming in. It's a fast scan, it's a cheap scan, so that any known malware, anything that it can block, it will block. From there, we will send the file to the CDR engine. If that file type is supported by the CDR engine, that will ensure that we don't send what we don't need to send to the sandbox, and avoiding the cost and latency of using the sandbox. And after the file is disarmed and reconstructed, it will go into our environment. So file comes in, multi-AV scan on the way. Once it's done, the file goes into CDR, is disarmed and reconstructed, and goes into the network. And this is the case where the file type is supported by the CDR engines. If the file is not supported by the CDR engines, such as executables, dynamic libraries, and so on, then after the multi-AV scan, we will send the file to the sandbox. Of course, that in this case, we will have latency, but it will ensure that no file will go into our environment unless it was scanned by multiple engines, and we have a safe file in our environment. So we've seen how to combine these engines to build an effective cybersecurity strategy for file channels, but on which channels should we deploy these solutions? And according to research and what we've seen, first and foremost is email. I think that more than 90% of file-based malware today is delivered via email. It would be, your safe bet to start with email to close that channel. Web uploads where available. We've seen a lot of digital transformation lately due to COVID. And a lot of businesses that used to have people come in with physical documents and photos, such as insurance companies, municipalities, that due to COVID needed to start receiving these materials digitally, and started opening their environment to uploads from the world. So we've seen a lot of attacks leveraging the fact that everyone quickly set up a digital channel to accept that data, and not always properly securing it. So that would be second. And third, even though it's 2021, portable media and files are still transferred via thumb drives and removable media, and that is always a threat. So we would suggest also protecting from that vector. Sorry. And for example, how we utilize this flow in Firewall for Office 365. So you see the file coming in from the left. First of all, the antivirus engines of Microsoft scan that file. After they are done, of course, if the file is blocked, then it is quarantined. It does not continue the process. The file is transferred to Firewall, where it undergoes CDR, policy enforcement, and a large variety of cybersecurity techniques. If the file is, and of course, if the customer has what was previously called ATP and now is Microsoft Defender for Office 365. If they have safe attachments enabled, then the file will also be sandboxed. If not, then the file is delivered to the user's inbox, and the user can start using the message and the attachment. We also talked about web uploads, and we've seen a lot of it, a lot of attacks going on through that vector lately. So you could also deploy this solution on the upload channel of your website. We have a solution called NetFolder that is used exactly for that. Every file uploaded to your website undergoes multi-AV scan, then CDR with everything in it, and you get a sanitized, disarmed copy of the file in the network. So that's all I've got for today. Yuda, you're still here?
Thank you so much, Omri. I really appreciate your remarks. If anybody has any questions or comments about the CDR process or how it complements sandbox technology, please check out odi-x.com or contact me at yehuda@odi-x.com. Have a great night, everybody. All the best.